All right, the next equation we're going to talk about is a combined gas law equation. And this chapter is kind of in reverse. I'll kind of do it this way, how the slides are laid out, so it makes sense. But it's a little bit in reverse, and I'll show you what that means. But this is a combined gas equation. It's a little different than the ideal gas equation in that you're not given one of everything, but you're given two of everything. So I'm given two pressures, I'm given two volumes, I'm given two temperatures. Okay, you might even given like two amount of moles, but we're not going to worry about that. So basically what it is it can be any combination of this. So I can have like a P1 V1 equals P2 V2 equation. Like for example, let's say the equation says I have pressure 1 changes to pressure 2 and I have volume 1. What's the new volume? And I say nothing about temperature, then the temperature is constant. So they cancel each other out. So this is kind of an all-in-one type of equation. You don't have to have all of the variables, all right? You have to have at least, like two of them, either pressure, volume, pressure, temperature, or volume and temperature. Or you can have all three of them. It just all depends on the problem, okay? There are a bunch of problems. I suggest you kind of do a lot of the problems to understand how to do this. Again, it's not hard, but you just have to practice. And remember, temperature, what are the units for temperature? Always Kelvin, always Kelvin. Your pressure and volumes in this case do not have to be in atmospheres or liters, but they have to be the same. So if you have a torr here, you got to make sure you also have torr here. If you have milliliter for V1, you got to make sure you have milliliter for V2. They don't have to be this. They don't have to be exactly what we did in ideal gas law, but they have to be the same for these equations. But your temperature does have to be in Kelvin. Okay, so here's a perfect practice problem. Okay, if a child releases a balloon, a 6.25, so that's my V1, liter balloon in a park, at an amusement park with a temperature of 278. So remember, we got to convert that to Kelvin. Okay, so that's 301 Kelvin. So that's T1. With the air pressure, here's my pressure, 757.2 millimeters of mercury. That is my P1. Okay, what is the volume? So I'm looking for the new volume, V2. If it's gone to an altitude where the temperature is minus 34, okay, so in this case, I'm going to take 273 and subtract it from 34 to get 239. So T2 is equal to 239 and a pressure of 366.4 millimeters of mercury. That's P2. Okay, so remember my equation is P1 V1 over T1 equals P2 V2 over T2. So all you do is you plug in the numbers. Okay, so pressure 1 is 757.2 times your V1 6.25 divided by 301. This equals your P2 366.4 times your V2, which is what I'm looking for, divided by 239. And basically you solve for V2. All right, we'll have it on the other slides. I don't have room anymore. So basically here's the equation, here's all the numbers, and you get 10.3 liters. Okay, so that's basically how you do a combined gas law. We have more than one variable. You just got to take all the variables and combine them, and you solve for one of them. But remember, your temperature is always here. Temperatures must be expressed in Kelvin. Always. Everything else doesn't matter as long as we are consistent. Look at that. It's even in the notes from the publisher. All right. I should have written this book. All right. We can use it. So for pressure, as long as these are the same units, it doesn't matter. If you want to convert to atmosphere, go ahead. But it's not going to matter. You're still going to get the same answer. Okay. This is kind of another equation. I'm not too fond of this equation because you don't see these types of problems a lot, but I will have it for you on the exam. And this is if you want to find a molar volume of gas. Remember, molar mass. Molar mass. You remember what the units are for a molar mass? It's even telling you in here, molar mass. What units are mass? Grams per mole. Okay, and you use the density. Okay, remember density is grams per milliliter. Okay, your R is your R value, your temperature, all right, and then you have your pressure, which remember is in whatever atmospheres or whatever, okay? So here's kind of a problem. If you want to go through the problem, by all means, go through the problem. Make sure you convert everything to the same units as we talked about, since your R value, remember, is atmosphere times liters over moles Kelvin. So your pressure better be converted to atmosphere. Your density, even though it's milliliters, that needs to be converted to liters because that needs to cancel out right there. Okay, so make sure you do that. Okay, so again, I would practice this problem. Make sure everything is converted in the correct units. All right, this is already in liters for you. This is not in Kelvin, so what you got to do, but that's already in atmospheres. So you can figure out the molar mass of CO2 by plugging in all those equations. Okay, so I will let you do that on your own. All right, so I'm going to stop there, and then we will pick it back up once we are done.